The question how old is the Earth has not been precisely answered. Because so far none of the scientists have discovered the way to calculate the exact age of the Earth directly from the rock samples, because most of the Earth's oldest rocks have been destroyed and recycled by the action of plate tectonic movement. So far, none of the Earth's primordial rocks have been found. However, the geologists have become able to determine the plausible age of the solar system, and thus calculated the accurate age of the Earth on the basis of the assumption that the Earth and the rest of the celestial solid bodies in the solar system came into existence at the same time, and are therefore, of the same age. The age of the Earth as determined by current methods of radiometric dating is about 4,600 million years. Before discovery of the radiometric dating, several attempts were made to determine the age of the Earth. The important ones are as follows. From the history of organic evolution. From the rate of sedimentation. From salinity of seawater. From the rate of cooling. As soon as the Earth cooled and solidified, life appeared on it. Initially, the organisms had a simple body structure. The complexity increased with the passage of time. The man, who has evolved quite recently, possesses the most complex structure. From the history of organic evolution, biologists have determined the age of the Earth to be about 1,000 million years. The other important method to calculate the age of the Earth is from the sedimentary rock formation. The formation of sedimentary rocks started with the solidification of the Earth. Hence efforts were made to calculate the age of the Earth from the rate of sedimentation in the oceans. The method involved was to determine the total thickness of sedimentary rocks that had been deposited during the Earth's history and then to divide it by the rate of sedimentation. This method gave an age of around 500 million years. This method had many difficulties, like different sediments accumulate at different rates under varying conditions. A rate of sedimentation determined for recent sediments cannot necessarily be applied to the past. The age of the Earth had also been calculated from the rate of salinity in the ocean water. It is assumed that the oceans originally had fresh water. If the amount of salt carried to the ocean each year by rivers is known, it can be calculated how much time it took to accumulate the salt that is now present in the oceans. This method gave the age of the Earth as about 120 million years. This estimate was not accurate as the rate of accumulation of salts could never be uniform through all the history of the Earth. In 1897, the British physicist Lord Kelvin calculated the age of the Earth from the temperature difference between the initial molten planet and its present state. He assumed that the rate of heat loss was constant throughout the Earth's history. This method gave an age equal to 20 to 40 million years, which was more than 100 times lower than current estimates. Kelvin also made estimates based on assumptions concerning the origin of the Sun's heat. The age of the Earth calculated by this method gave similar results. Kelvin's estimates for the Sun and the Earth were wrong, because he did not take into account the fierce heat generated by the decay of radioactive elements. But in recent studies and research, the radiometric method bears maximum importance. The methods of radiometric dating are based on the radioactive decay of certain isotopes that have very long half-lives. The radioactive isotope is often referred to as the parent, and the elements resulting from the decay of the parent are called the daughter products. The age of rocks and minerals that contain radioactive isotopes is determined by measuring the accumulation of the daughter products in them. This procedure is called radiometric dating. Radiometric dating is very reliable because radioactive decay proceeds at a constant rate and it remains unaffected by any physical or chemical agents. A commonly used term in radiometric dating is half-life. It is a common way of expressing the rate of radioactive decay. Half-life may be defined as the time required for a given amount of radioactive substance to decay to 1/2 of its initial value. For example, the half-life period of uranium-238 is 4,500 million years. This means that in 4,500 million years 1 gram of uranium-238 would be reduced to half a gram, the rest having been transformed into the lead-206. Of the many radioactive isotopes that exist in nature, only 3 have proved useful in providing radiometric ages for ancient rocks. These 3 isotopes are uranium-238, potassium-40, rubidium-87. The methods which are commonly used for dating rocks include potassium-argon, rubidium-strontium, and uranium-lead. The basic equation for calculating the age of a rock sample is as follows, where Nd is the number of atoms of the daughter product. Np is the number of atoms of the parent radioactive substance present today and T is the half-life of the radioactive substance.